Now, both voice and data services use twisted pair communications wire. It's called twisted pair, or TP, because it's got 4 pairs of wires twisted together. Older telco cable had 4 untwisted wires, called quad cable, but it's no longer used in new installations.
The pairs of TP cable are 22 or 24 gauge copper, and the insulation is color-coded to help identify the pairs easily. One wire usually has a solid color, and the other wire of the pair is white or is white with colored stripes. Now, the pair with the blue and blue-white stripe, for example, is simply referred to as the blue pair. When used for telephone voice applications, each pair of wires is capable of carrying one standard telephone line. The blue pair is used for line 1, the orange pair for line 2, the green pair for line 3, and the brown pair is used for line 4.
In order to handle high data rates, newer high-performance TP cable called category-rated cable should be used. Category ratings were established by the Telecommunications Industry Association to standardize performance ratings of cable and equipment.
The ratings give the minimum performance requirements for attenuation, resistance, interference between pairs, and so on. Category ratings start at Category 3. Category 3 cable, or Cat3, is used for medium-speed communications up to 10 megabits per second over distances of up to 100 meters. Category 5 cable, or Cat5, shown here with Category 3 for comparison, is used for high-speed communications up to 100 megabits per second at distances of up to 100 meters.
A higher performance version of Cat5 cable called Cat5e for enhanced is now also readily available.
It has tighter specifications on crosstalk and attenuation performance, although still rated for 100 megabits per second service. And since Cat5e will easily handle all of our voice services, we're going to use it for all of our voice and data wiring. It'll also handle other applications such as audio and video distribution if installed correctly. Category 6 cable is designed to handle data transfer rates up to 1,000 megabits per second by sending data at 250 megabits per second over all 4 pairs simultaneously. The cable incorporates new designs to physically separate the pairs to reduce crosstalk, such as a plastic separator, such as this, or by using a flat jacket molding, such as this. TP cable always uses the TP modular connector developed by AT&T. They come in 6 and 8-pin styles. The male plug is always used on the cable, and the female jack is always used on equipment or wall plates. You'll hear these connectors referred to as the RJ11 style for the 6-pin variety and the RJ45 for the 8-pin style. Now, these are the old AT&T registration numbers for the tariff use for the services the jacks were intended for and are no longer used, although the terms persist. They're just the 6-pin and 8-pin modular connectors and jacks. Now, the pins on all the jacks are numbered from left to right looking into the jack. The 8-pin jack is specified in the TIA 570 for all residential voice and data applications. The blue pair is connected to the center 2 contacts. The orange pair is connected to the next 2 contacts out. Now, this maintains plug compatibility with the 6-pin style connector. The green pair is connected to pins 1 and 2, and the brown pair is connected to 7 and 8. Now, this wiring configuration is also standard for the commercial TIA 568 specification and is referred to as the T568A wiring configuration, or just the A configuration. Now, there's an alternative 8-pin wiring configuration called the T568B. Now, this configuration swaps the green and the orange pairs on 1 and 2 and 3 and 6. Now, it's used in some commercial installations, and you'll see it on some jack labeling, usually just with the letter B. You must use plugs and jacks that are able to maintain the category rating of the cable being used. Nearly all plugs and jacks you buy are rated for Category 5 service and use these insulation displacement contacts. In this course, we're going to concentrate on data networks used to support computer applications and broadband internet access, as well as distributing real-time audio and video. Now, data networks in the home use Ethernet network technology, developed in 1972 by Bob Metcalf, a very bright engineer working at Xerox. It's simple and reliable.
Ethernet is a local area network or LAN technology. It transports data within a home or office at rates typically between 10 and 100 megabits per second. This diagram illustrates a typical Ethernet network. All data outlets are home run to the distribution center and connected to a device called a hub or switch. This design, or star topology as it's called, allows any connected device to communicate with any other device on the network, sending text, pictures, music, and control information. The network can also be connected to the Internet through a router and gateway device, such as a cable or DSL modem.
Ethernet is an IEEE standard, often referred to by its standard number, IEEE 802. The most common form of Ethernet for computer networks is referred to as 802.3.
802.3 is commonly referred to as 10 base T, meaning 10 megabits per second, baseband, remember baseband, on twisted pair cable. There is also a 10 base F, or 10 megabits per second over fiber, and 10 base 2 and 5, which covers 10 megabits over coaxial cable. 802.3U is the specification for fast Ethernet, or 100 base T, 100 megabits per second over Category 5 or better twisted pair cable. 10 and 100 base T are the de facto standards for the home. There's even a faster version, 802.3AB, for 1000 base T. This requires Category 5E or 6 TP cable. Ethernet transports data from one device to another in discrete chunks of data referred to as frames. Now, a frame consists of a preamble, a to and from address, the message payload, and an error detection field comprising from 64 to 1518 bytes. Now, the data to be transported is fragmented into pieces that'll fit into the frame by the sending application and reassembled at the receiving device. The to and from address is the physical Ethernet address of the receiving and sending device on the network. It's a hardwired 48-bit address assigned by the manufacturer. Every Ethernet-enabled device should have its 48-bit address visible on the product, written in hexadecimal notation, using the numbers 0 through 9 and letters A through F.
While Ethernet can transport any kind of data, most of the time it's transporting TCP/IP packets, the protocol and data format used over the Internet. Now, using TCP/IP for home networks allows an easy and seamless connection from devices in the home to the Internet, a major advantage. And it's not just for computers. More and more AV equipment, home automation system, even appliances are relying on an always-on broadband connection to the Internet for everything from monitoring to content download.
TCP/IP stands for Transmission Control Protocol and Internet Protocol, the transport and network layer protocols used on the Internet. TCP/IP packets are the Ethernet frame payload. They have a to and from IP address, routing and control information, source and destination application ports. These are like internal addresses for applications sending or receiving the data. And the real data payload. This might be part of a picture, a web page, or an MP3 file. IP addresses are only 32 bits or 4 bytes and are written in what's called dot decimal notation, a decimal number for each byte separated by a dot. It's pretty strange, but we're stuck with it.
Every device in the world that communicates on the Internet has got an IP address. Therefore, every device on the home network has got both an Ethernet address and an IP address. But unlike Ethernet, IP addresses can reference devices in the home, a private IP address, or devices outside the home, anywhere in the world, using a public IP address. But the problem is, with only 32 bits, there are not enough IP addresses to pre-assign one for every IP-enabled device. Therefore, the IP addresses have got to be assigned either manually or with address assignment software, usually built into the home router. Now, we'll demonstrate IP address assignment in Part 4.
The Ethernet data network is physically installed like the voice network. Home-run cables are installed from outlet locations where data network access is desired back to the distribution center. Computer and peripheral devices simply plug into